Cool. Hi, everybody. Good afternoon. My name is Vikram Hosakote. I'm a senior software engineer at Cisco Systems. I'm also a core reviewer and a core developer for the OpenStack Koala project. Koala is about deploying OpenStack in Docker containers and how we can use containers to deploy cloud services. So today's talk is about multi-node ZUUL gate for bare metal and Docker. So I'll explain how the OpenStack gating system is slightly moving towards bare metal and containers from just a single node all-in-one dev stack gate. So the agenda for the talk is I'll explain what is ZUUL, basically. ZUUL for OpenStack gating, ZUUL architecture, ZUUL Jenkins integration, ZUUL with multi-node and bare metal, and finally ZUUL with Docker containers, and then question and answer. So what is ZUUL? In the movie Ghostbusters, ZUUL is the demigod and gatekeeper of Gozer, the destructor. So if you've seen the Ghostbuster movie, we all know what ZUUL is. But in OpenStack, ZUUL is a program used to gate the source code repository of a project so that changes are only merged if they pass tests. So if you are contributing code upstream, how many of you contribute code here upstream? Yeah, so if you contribute code upstream, you'll know that it's not so easy to get code merged. It has to go through review, and then it has to pass the gate, and it has to pass sanity tests and all that. So ZUUL is a single system that does all of that for you. It does voting in Gerrit. It runs sanity tests. It also merges code. If you're a core reviewer, you can use the workflow option of ZUUL to merge new code into upstream master. ZUUL for OpenStack gating. So ZUUL is a pipeline-oriented project gating system. So it's mostly sequential, one after the other, although two reviews or two jobs can run in parallel. Each task in each job is mostly sequential. So the way it works is it uses a lot of git commands underneath. So it takes the new code, it pulls the latest master, and then it does a round of rebase. And then if there's no error from the rebase, it's going to go through the ZUUL parameters and then decides what to do with the review. Usually it's just check for PEP8, Pi27 test, Pi34, Bash 8, some sort of static sanity analysis, and also some level of functionality testing. Like it can run Tempest, it can run even rally scale tests to kind of validate the new code that's going to be merged. So it facilitates running tests and automated tasks in response to Gerrit events. So we can hook Gerrit events to ZUUL. So we can say what should happen when somebody commits new code or pushes new code for review. What should happen when somebody posts a review comment. What should happen if somebody does -1, -2, +1, +2, and it also has options for like fast merge, where a core reviewer can merge without the mandatory 2+2s if it's a really critical bug fix. So the architecture, ZUUL has many parts to it. Most of it is used for single VM dev stack gate. A lot of it is used. I mean, some of it is used for multi-node, not all of that. The multi-node architecture is evolving, so this is for the single node architecture, and I'll show in the next slides how the multi-node architecture looks. So ZUUL has connections which take incoming requests and reply to Gerrit and SMTP protocols. It has triggers, so you can set up triggers through Gerrit. Timer-based triggers, so say if a review is sitting in the queue for like 3 months, 4 months, you can trigger timer-based events. And ZUUL has built-in triggers, so say master has a bug and is in bad shape, without interference from a human being, ZUUL will block the merge, so we don't further break the master, which is already broken. So ZUUL has a lot of built-in triggers. It has reporters, again, Gerrit and SMTP, so it reports back into the connections. So in the form of voting, emails, it can also send nice bar graphs and pie chart. ZUUL Cloner is a component in ZUUL that's used to customize the activities in the gate. We can use ZUUL Cloner to customize upstream gate to an internal gate, behind a firewall on a corporate network. And then it has launchers, which is basically the integration with the CI/CD pipeline, which uses the Gerrit Jenkins plugin. It has great stats de-reporting, which reports metrics. And then finally, ZUUL client, what the user actually uses to interact with ZUUL. So that's the architecture. So new code is submitted for review, and then that enters the code review Gerrit system. And then an entry is made into Launchpad that the new code is submitted for review. And then ZUUL is triggered. ZUUL is integrated with Jenkins that checks for the return code of the gate, if it passed it or failed or blocked or errored out due to some syntax error. And Launchpad is synced with GitHub. So as soon as new code is merged into upstream, it's automatically mirrored to GitHub. So the new code shows up in GitHub as well. So this is the architecture that's actually evolving every day almost for the multi-node. So upstream infra has a project called Node Pool, and that's a bunch of nodes. And by default, it's just a single node and an all-in-one dev stack is instantiated and run. But we can customize Node Pool and make ZUUL create multiple VMs, and then network the VMs, and then create a multi-node cloud, like a controller compute network node. ZUUL Jenkins integration, this is pretty much standard. It's same for single node or multi-node. It uses the Gerrit Jenkins plugin. So basically, it takes arguments from ZUUL and it passes them as build arguments to Jenkins. And then Jenkins will do the rest of the build stuff, like it builds the code and then returns an error code back to ZUUL. And then ZUUL is going to use the return code and vote on the review in Gerrit. That's the link for the Gerrit plugin documentation. This is a sample of how the Jenkins Git SCM plugin configuration should look. We mentioned the repo URL, the ref spec, and then the branch specifier, and then some clean parameters. Most of this is automatically generated from the Git review, like the commit hash and all that. but there is a way to manually update the file. For bare metal, ZUUL v3 has bare metal. It's very user-friendly. The user just has to write a YAML file and just say what host is what role in the cloud, like controller, and then mention the role, which is a regular Ansible role, compute, and then ZUUL compute, and the list can go on, like add network node, add HA proxy, add multiple nodes in the YAML file. And ZUUL v3 automatically is going to scan that YAML file and create multiple VMs. And to use bare metal, ZUUL by default creates DevStack. So the first step would be to replace DevStack VM gate with bare metal orchestration, which ZUUL v3 does already. And it can also be integrated with Ironic. So the bare metal orchestration can be done using Ironic, and you can load operating systems onto all the nodes and kind of bootstrap them and then set them for ZUUL. And then ZUUL is going to use those multi-node, multiple VMs to do gating tests. And finally, Docker containers. Many projects run ZUUL with Docker. This is just an example with Kala, which I'm working on. Kala runs OpenStack in containers in the gate, and those are the links. And usually these links are used as a reference implementation for running gate in Docker containers. So each OpenStack service is in a separate container, and ZUUL is going to check or run tests and make sure they are sane and kind of sanitize those containers. Some useful links here. The ZUUL code base upstream, ZUUL documentation, project config. Project config is a project that's tied to the ZUUL project where all the configuration parameters are maintained, and then the Jenkins website. I can answer any questions if anybody has any questions. That's it. Thank you.